Okay, so now that we know how to find a remainder, we need to discuss how the remainder fits into what we call factors and how factors fit in with zeros and just how all of these things relate together. And so I want to take things back to elementary school here for just a minute and discuss factors. And so let's just talk about this for just a second. Let's say that I have the number 20. What would you say the factors of 20 are? Well, hopefully you would say, for example, 1 and 20, and 2 and 10, and 5 and 4. And those are the factors of 20. Now, why are those factors of 20? Well, it's because by definition, whenever you divide 20 by any of those 6 numbers right there, you're going to get a remainder of 0. Or another way to say that is when you divide 20 by one of its factors, they go in evenly to the number 20. So what about a number that's not on this list? So let's say 7 is not on this list. Why is 7 not on the list? Well, it's because when you divide 20 divided by 7, that 7 goes into 20 twice, but it has a remainder of 6. And the fact that it has a remainder at all tells me that it is not a factor. Whereas if you were to take 20 divided by, let's just say 10, that would equal to 2 with a remainder of 0. And so what that means is that 10 is a factor of 20. So why is that important? Because if I want to determine if something is a factor, all I really need to figure out is what the remainder is. If the remainder is 0, for example here, then the number is a factor. If it is not 0, then that is not a factor. And so that's essentially what we're going to be doing here, is figuring out what the remainder is so that we can make the determination, is that linear binomial? So for example, here in this example 4, is x minus 3 a factor of this big long polynomial? Okay, so let's figure that out. Use the factor theorem, which is essentially what I've just illustrated with elementary school numbers. Use it to determine whether the first polynomial is a factor of the second. So the first thing I want to do is find the remainder. Now you have 3 options for doing that, and we discussed those earlier in the notes: long division, synthetic division, or remainder theorem. I highly prefer the remainder theorem because, hello, it's very fast and easy. So what number do I need to plug in here to figure out the remainder for x minus 3? Well, that would be positive 3. Okay, because if it's x minus 3, if you were to set that equal to 0, you would get positive 3. And so f of 3 is what I'm going to have to find here in order to determine the remainder. So plugging in 3 for x is going to give me 3 cubed minus 3 squared minus 3, and then minus 15. And if you have a calculator, you can just type that all in all at once. I don't have a calculator sitting next to me, so I'm going to just evaluate this by hand. 27 minus 9 minus 3 minus 15. And so that is going to be 27 minus 9 is 18, minus 3 is 15, minus 15 is 0. And so because I got a remainder of 0, a remainder that equaled to 0, what I can say then is the conclusion: x minus 3 is a factor of this function. And normally we would give it a name, but I didn't give it a name here, so I'm just going to write it out. X minus 3 is a factor of that particular function. And again, the reason I know that is because I found the remainder and it was equal to 0. If the remainder had been any non-zero number, then I would have to say that no, it is not a factor of this particular polynomial. Okay, in example 5, the directions dictate that we want to completely factor this polynomial. We are given a graph and told to use synthetic division in order to get this accomplished. And so if you take a look at this graph, hopefully you can see it pretty well on your paper. Notice that I have 2 really what I would call nice zeros on this particular graph. I have a 0 at x is equal to -2, and another 0 at x is equal to 1. Now, I've got a third 0 here, but I can't really tell you what that is just by looking at the graph. X equals -2, x equals 1, I feel good about those, but that third one, I just don't know what it is. And so I can tell you, because x equals -2 is a 0, that x plus 2 has to be one of the factors of this polynomial f of x. I can also tell you that x minus 1 has to be another factor, but I'm missing that third factor because I don't know what the 0 is. So how am I going to find that 0? That's where synthetic division comes into play. So if I list the coefficients of this polynomial f of x, that's going to be 3, 4, -5, and -2. And so I got that from right up here, looking at the coefficients of f of x. And what I'm going to do now is divide synthetically using both of these zeros. And so which one you use first is really up to you. It doesn't really matter a ton. I'm sort of a positive person, and so I'm going to choose the positive one first, and then I'll do the negative one second. So leave a little bit of space and drop down that first number. It's a 3. Multiply 3 times 1, which is 3. Add to 4, that gives me 7. 7 times 1 is 7, plus -5 gives me 2, and 2 times 1 gives me 2, which gives me a remainder of 0. And that should make total sense, because we already said that 1 was a 0, and x minus 1 was a factor. And so, of course, the remainder should equal to 0, and if that doesn't make total sense, go back and look at those 5 equivalent statements on the previous page and see if that maybe helps. Now, I'm not going to start over this synthetic division. I'm going to keep going with that as my new line and put my other 0 here and go to work. And so first thing I'm going to do is drop down the 3. I'm going to multiply 3 times -2, which is going to give me -6, and then add, which is going to give me 1, multiply by -2, which is -2, and once again, just as I predicted, I'm going to get a remainder of 0. Now, what does this last line represent? Well, this first line started with an x cubed. When I synthetic divided the first time, I got down to an x squared. When I synthetically divided the second time, that got me down to x. And so this last line represents another factor, which is 3x plus 1. And then I know the other two factors already. I was able to determine those up front, x plus 2 and x minus 1. And so fully factored f of x is equal to this right here, using synthetic division and getting those two zeros from the graph.